So today we're going to start graphing linear inequalities. We've been graphing linear equations, and you all know that those are solid lines on a coordinate plane represented in slope-intercept form or standard form. So the only thing really changing is that now we go to linear inequalities, okay? Meaning they're going to have some type of inequality symbol, and those look a little bit different on a graph. So remember that our inequality symbols are greater than, less than, greater than or equal to, and less than or equal to. So it's basically the same concept, but there's a few more steps. Just like there's a few more steps in solving inequalities rather than equations, there's a few more steps to graphing inequalities over equations. Okay? All right, so a linear inequality, Ms. Delk's already written your definition. It's similar to linear equations, but these use an inequality symbol. So her symbols are here that we're showing you. All right, and basically on this, we are looking for solutions. She's highlighting that because everything that would be a solution is all of the ordered pairs that make the inequality true. Basically, we can plug in X and Y into the inequality, and all of those pairs should be represented in the shaded area of the graph, okay? So notice that she's put, we're going to represent it by shading. This will be the first time you've ever shaded a graph, but all that shading includes every point that would make that inequality true. All right, so the first part they want us is to determine which ordered pairs are solutions to the linear inequality below. Okay, we're going to do this algebraically first and not graphically. We're going to kind of show you what the point of the graph is over in algebraic form instead of graphing. So they ask us to plug in to 2x minus 3y is less than 15. And you all know that ordered pairs are represented by x comma y. So see Ms. Delk, she's using substitution property. When she uses substitution property, she plugs it in parentheses into the equation, and we're looking for it to be true. So notice she plugged in 2 for x, 5 for y. She got 4 minus 15 on the left side, which is negative 15. And that's less than 15, so that is true. Meaning that if we graph this on a coordinate plane, this is a point that would be shaded. That would be in the shaded area. Okay, so see what she's doing. She's simply plugging in x and y, looking for true. Obviously, the second one she plugged in, 19 is not less than 15, so we just put a no. Meaning that when we graph this linear inequality on a coordinate plane, this point would not be included in our shaded area. Okay, so that's an easy little algebraic thing. Y'all know how to plug in, you know how to do all that. You're just looking for true statements.
And notice that with these, there's usually more than one.
There's technically millions of them.
And that's why we're going to use the shaded area. The shaded area shows all the points that make that inequality true.
Okay, so see what she did here, the math. She did algebraic math right here. She found that these 2 points would be included in the shaded area. These 2 would not. And when we get down here and actually graph this, let's hope that 2, 5 is shaded, 0, 0 is shaded, but these 2 points are not in the shaded area. All right, so first thing you're gonna do, we're gonna put the inequality into slope-intercept form. We go to slope-intercept form basically because we can see the red flags that happen when we're changing. We can also know that you all can graph that because it's the same thing. You are great at graphing y equals mx plus b. So if we're going to graph it, we definitely go to slope-intercept form, and we're going to watch out for red flags. Remember, that's when you multiply or divide an inequality on both sides by a negative number. Okay? So that's what you really got to worry about this week is, are you multiplying or dividing on both sides by a negative number? All right. Then when we graph the line, we've kind of talked about this for the last few weeks. All right, we're going to use a solid line. So what you're used to when it is less than or equal to or greater than or equal to. Basically, if it's got an equal to, it's a solid line. Just like that would have been a solid bubble on your number line when you were solving these, it would be a solid line on a graph. Okay. All right, one little change. This is the first time you've ever seen this in math. If it is a dashed line, we're going to go for less than or greater than. Just like remember, back when we were graphing these, we would have had an open bubble, right? You would have been open bubble, and then this is the representation of an open bubble on a graph. It's basically opened lines.
And remember, if the inequality sign is missing its line, then part of your line must be missing.
Yes, I think
It's
that.
missing, it's missing.
And look, it's here, solid, it's solid. That's kind of how you remember it. All right, then the shading part. So another new little thing you've never done before is you've never shaded a graph. I tell my kids, like the first time we ever get to color in math. All right, we're going to shade above for the line if it is greater than or equal to. Just think about greater. You're above think about being greater than. You're above things.
You're the best.
You're the best. So you're going to grow above the line. You're going to shade above.
Miss Fisher likes to shade. We're going to shade to
Heaven. Because I think if you're greater than, you're going to heaven. So I like hold my paper up and look where I'm going to heaven. Okay, whatever shading part would take me to heaven. All right, we're going to shade below the line if we're less than or equal to. Just like I say, if you're above, you go to heaven. If you're below the line, if you're less than, you're going to hell. So I always say, like, shade it towards hell. Think about going down. Less than would be down, like going towards hell. Greater than would be going towards heaven, going up. Okay, it kind of makes sense, and it'll make it just where you can remember it. Okay, notice this is the one that we pulled from up here. So we've already proved some of this algebraically. Now we're going to graph it.
to show all solutions.
Yeah, because those we just picked some for, and that's what we saw. Ms. Delk's going to first put it in slope-intercept form. She's going to watch out for those red flags. Oh, she's fixing to have a red flag because she's dividing everything by a negative number. So you're dividing both sides of an inequality by a negative number.
So I must flip the inequality symbol before I can continue.
You all remember that from when we did inequalities. So in slope-intercept form, she has y is greater than 2/3 x minus 5. So let's see what that's going to mean. That means that we're going to have a dashed line and we're going to be above it. But notice that looks like everything, you know how to graph that. You're going to hit at 0, -5, and you are going to have a slope of 2/3. So notice she's kind of making herself some notes, dashed and above. So watch her graph this. She's going to hit at 0, -5. She's going to rise 2, run right 3, everything y'all know how to do. She's just going to pay attention to what happens. So she's got her straight edge here. Remember that this is a dashed line because we are only greater than. So the part of the inequality is missing, therefore part of our line is missing. She's going to put those arrows that we love and that you have to show that it goes on forever. Okay, notice now, if you need to hold the paper up, I'm going to try to turn this. So hold the paper up. This way, if you shaded, would to go towards heaven. This way, if you shaded, would go towards hell. Well, we want to go above because we're greater than, so Miss Delk is going to shade this way, going towards heaven.
Up to the boundary line. In math, we call the line that we just graphed the boundary line. And I'm going to shade above, kind of messily. Just to show that everything in there that I shaded is a solution. That means I have solutions in quadrant 1, quadrant 2, quadrant 3, and even some in quadrant 4. However, I cannot include the boundary line because it's not equal. That means if I were to plug these points in for x and y over here, they would not make it true. So anything in this shaded area is a solution up to the boundary line, but not included.
So watch what we said up here. We said that 2,5 would be a solution, and watch where 2,5 is on Miss Delk's graph. Notice it's in her shaded area, which is perfect. It should be shaded. Okay. Notice that -1, -7, if we could show it, it'd be down there, and it would be not included in the boundary line nor the shading. It is not a solution. Okay, she's going to show you 3, -4, and watch where it lands, just outside, so it's not shaded and not on a solid boundary line, therefore it's not a solution, and we already said it wouldn't be algebraically. And then, of course, 0, 0 is in our shaded area, so therefore it would be a solution. Notice there's billions of points in here that would be solutions, but there's also billions that wouldn't be.
Yep.
Okay? All right, we're going to flip over.
Let's do a couple more.
All right, which one do you want to do?
Okay, let's do, you want to do number 6?
Sure.
Okay. Notice how I'm not in slope-intercept form because y is not by itself, so I'm going to isolate the y, looking out for red flags always.
Remember that her goal is slope-intercept form because you all are great at graphing slope-intercept form. So take everything to slope-intercept form before we graph it. And it just shows red flags better than standard form. So see what she did?
No red flags on that one. That was nice. Okay, because it's not equal to, this is going to be a dashed line. This time I'm less than, so I'm going to shade below. I'm going to shade towards hell.
Less than people, we go below the line, so we're going towards hell. If you need to hold your paper up, you can see it.
Okay, my beginning is at the origin, so I'm going to begin right here at the origin. I'm going to fall 3, run right 2, so 1, 2, 3.
Just like y'all know how to graph. If it said y equals -3/2 x, we all know how to graph that. It's the same thing. You just got to worry about your lines nowadays and your shading. That's why most of the time y'all are super good at this is because you know how to graph it. The only part you're going to mess up is the line or the shading.
Okay, I'm going to take my straight edge. I'm going to line it up. But not draw a solid line. It's dashed. It's not equal to it.
And remember, it was missing that line underneath her inequality, so part of her line is missing.
Notice how I try to extend it past the graph a little bit. It helps when it comes to shading. We always put arrows because this line is continuous. It would go on forever if I had a bigger graph.
Okay, so these are kind of hard to see which one would be below and which one would be above.
Okay,
so
I'm going to hold it up.
We're going to hold it up. Okay, think about where you would shade to go below the line.
Right here, if I shade it that way, that's heading up towards the sky. That's going towards heaven. If I'm on this side of the boundary line, it's going down towards the bottom. It's heading towards hell. And if I'm less than, I'm beneath the line, so I need to shade all down here. So going back down, I go up to the boundary line, but not past it. So everything up to that boundary line, kind of messy, just to show it.
Okay, see what that looks like? All right, here's the goal, and this is what you got to understand. All of these points in the highlighted area, in the shaded area, if we picked a point and plugged it into this inequality, it would be true. Whatever happened would be true. Okay, well, if we picked points over here that are not highlighted, they would not make this true. All right, and then the biggest thing for y'all to understand is if we picked a point on a dashed boundary line, remember that it's dashed, so it's not included. So therefore, if these points right here, like 0, 0s on that boundary line, in a dashed way, if I plugged him in, he would not be true. Think about me plugging in 0 for x and having 0 for y. Well, -3/2 times 0 would be 0, but 0 is not greater than 0. Therefore, it would not be true. We would need this to say equal to for that to be true, but it's not. So remember that dashed boundary lines do not include solutions to this inequality.
So if I asked you where are the solutions, you could tell me there are solutions in quadrant 2, there are solutions in quadrant 3, there are solutions in quadrant 4, and I cannot include the boundary line. It is excluded from my solutions. Okay, let's do another one. Let's do number 7.
Ooh.
Okay, number 7 is tricky. Notice that y is by itself, but this is one of our special cases because I have y in just a number. So this is either a Vux or a Hoy line. Because I have y, this is definitely a Hoy line. This would make a Hoy. Meaning I'm going to have a horizontal line at where y is -4. But I have to be careful because it's not an equation. I can't just start graphing. I have to ask myself, solid or dashed? In this case, I have a solid line because it's equal to. Notice how it's got the line. So I'm going to have a solid line.
So see how Ms. Delp makes her notes just so she doesn't forget over to the side? That's a good little practice to start.
Yep. And then because it's less than, if someone's less than you, that means they're beneath you. We're going to shade below. So we're going to shade to hell. So I've got my y-intercept. I told myself it's a solid line, so I'm going to graph a solid line right here. If I were to shade on this side of the line, that's going up towards the top. It's heading towards the sky. That's going to heaven. But I'm below, I'm beneath. I have to shade towards the bottom. So towards hell.
Okay, what she's shading, every one of these points, if you plugged it in right here, would make this inequality true. Now, this is the first one we've done where the boundary line is also included. So we could pick every point on this boundary line, plug it in, and it would be true. Okay, so like right here, this would be 1, -4. So the y value of that point would be -4, and -4 is less than or equal to -4. Notice how that's true.
Because it satisfies the or equal to portion. So if I asked you where are your solutions, you could tell me they're in quadrant 3, they're in quadrant 4, and the boundary line is included. Okay. You want to do number 8?
Let's do 8, yeah. Those always seem to be
Okay,
harder.
here's another one. Notice this case, I don't have a y at all. I have x and a number. So rather than this being a Hoy line, this is a Vux.
Another one of our special cases.
So I'm going to go where x is 7. But I have to be careful because it's not an equal sign. That's an inequality. It's missing the line. That means part of my line has to be missing. So I'm going to have a dashed line.
Notice she writes it again, like a little practice to just get in the habit of.
And technically, because it's greater than, I'm going to shade above. But we're going to have an issue here in just a minute, and you're going to see why. So I'm going to graph a dashed line right here at 7. A perfect vertical line, straight up and down.
See, her line is missing, just like the line was missing from underneath her inequality.
And I'm supposed to shade above. Well, this line does not have an above. It has a left and a right. Because of that, we have to go back to our inequality symbol. Notice that if the variable is on the left, the inequality symbol turns into an arrow and it tells us which way to shade. It says shade to the right because those are the x's that are bigger than 7.
And y'all, you knew if you got that solution on the number line, y'all would shade every number greater than 7. Ms. Delp is shading every number greater than 7 on the x-axis. So like this is 8, 9, 10, 11, and her shading could continue this way forever. Of course, we just ran out of graphs, so we're going to stop right there. And notice all these x values, they would be less than 7. So that's why none of this is shaded, is because it can't make this true. Should we do one more easier one?
Yes. And if we asked you where are the solutions, remember you have solutions in quadrant 1, quadrant 4, but the boundary line is excluded. I say let's do number 2.
Yeah, that's the one I was going to pick too.
Okay. Oh, great minds think alike.
There we go.
Okay, notice this one was nice. I'm already in y equals mx plus b format. Okay, remember, it's not an equal sign, it's an inequality. Because it has its line, I'm going to have a solid line.
Think about which way that is. Is it greater than or less than?
If
Well, it
someone's-
looks like an L, so it's a less than.
And if someone's less than me, I'm going to shade below. I'm going to shade towards hell.
This one will be easy to graph because we're already in y equals mx plus b. So Ms. Duck's going to hit at 0, -1.
And then I'm going to fall 2, run right 1.
And she's already made her notes to herself whether her line is going to be dashed or solid and which way she's going to shade.
And notice that I'm shading every point possible.
She's doing that so that your shading is correct by shading every point. If you just showed a little bit of the line,
You might get off.
right.
Might get off kilter. So I'm
Okay.
going to take my straight edge. We always want straight lines. It's a solid line because it has a line underneath the inequality sign. So I'm going to connect.
Put those arrows like we like. Lines go on forever, otherwise it's a line segment.
Hey, remember, below is going to go towards hell. So if I shaded this way, that's heading up towards the top of my paper. That's going to heaven. This side of the boundary line is going towards the bottom. That would be shading towards hell. And that's where I need to be. Remember, the shaded area represents all of the solutions. So in this problem, the solutions are in quadrant 2, quadrant 3, quadrant 4, and I can include the boundary line because it's solid.
That means if she picked 0, -1 as a point, if I plugged in 0 for x and -1 for y, I would have -1 is less than or equal to -1. That's a true statement, so the boundary line is included. If we chose points over here, they would not make this true. Remember, if we chose points in the highlighted, we could plug them in, check that there would be true.
Okay, you have 3, no 4, I lied.
4.
There's 4 for you to try. We left you a nice easy one. And then these, notice that you're going to have to get y by itself. Make sure you look out for red flags, because if you have a red flag, you must change the inequality symbol.
Okay. Come in with questions tomorrow. We'll do some practice.
Yep.